Hello friends, welcome to my channel. So let's have a look at problem 885 together, the spiral matrix 3. So here and in this video, we're going to share a rotation matrix method to this problem again. So actually for the rotation matrix method, we have used it to solve Leetcode problems 23, 26, 54, and 59. So the details about the method were explained in Leetcode 23-26 video. So you are encouraged to watch if you are curious about the details. So for here, we're going to first read through the statement of the problem and then analyze a generic example, that is example 2, and then we share the code. First, let's look at the statement of the problem. So we start at the cell position R start and C start of an rows by columns grid facing east. So the east is the initial direction. So the northwest corner is at the first row and column in the grid, and the southeast corner is at the last row and column. So we will walk in a clockwise spiral shape to visit every position in this grid. Whenever we move outside the grid's boundary, we continue our walk outside the grid, but may return to the grid boundary later. Eventually, we reach all rows times column spaces of the grid. So we are required to return an array of coordinates representing the positions of the grid in the order we visit them. So the constraint about this problem is that the rows and columns is bounded above by 100, and the initial position is within the scope of the grid. So that's about the main statement. In example 2, so we are initially at position 1, 4, that is the 1 position. Then we move to the right 1 unit, then downwards 1 unit, to the left 2 units, up 2 units, and right 3 units, and downwards 3 units, and to the left 4 units. So then the pattern actually is easy to spot. So before we go to details about the example, let's emphasize the method. So the method we are going to use is the rotation matrix method. So again, for this method, 2 questions is to be asked. First is where to change direction. And second is how to change direction. How to change or update direction. So let's first answer the first part, this how to change direction. So we need to this where to change direction. We need to locate the position where we need to change position. So for this, we can track the steps we traverse from the starting position. For example, in example 2, so we walk to the right, say 1 unit. So that is 1 step, and then we walk downwards 1 unit, right? And then we walk to the left 2 units, then above 2 units, and to the right 3 units, and to downwards 3 units, and then to the left 4 units, and up 4 units, and continue. So in general, it's K and K, and then so continue. So that's the number of steps we walk each time we change direction, right? So we just need to mimic this step sequence, then we can know how to change where to change direction. So actually, in order to recover this sequence of walking steps where we need to change direction, so we can do things like this. So this is the recursion relation for generating this sequence. So for example, so you can check if n equals 0. So what we get? We get 1. So if n equals 1, what we get is also 1, right? Because 1 divided integer division by 2 is still 0. So if n equals 2, so what we get is 2 divided by 2 is 1. So 1 plus 1 is 2. So if n equals 3, so we get 2 again. So 3 divided by 2 integer division, that is 1. 1 plus 1 is 2. Then you can see n equals 4, you get 3. N equals 5, you get 3. And n equals 6, you get 6 divided by, this is a 4, right? So if n equals 7, 7 divided by 2 is 3.5, so integer is 4. So right, so on and so forth. You can try n equals 8, so you get 5, right? So if n equals 9, you also get 5. So I guess we read enough. So that's the way we track the steps. So we walk to a direction, and each time we finish the walk of this number of steps, we change direction, right? So here we walk to the right 1 step, then we change direction. Downwards 1 step, we change direction. To the left 2 steps, we change direction. So each time we finish one of these numbers, we change direction. So that's the answer to the first half. And then how to change direction. So that's the role of rotation matrix. So for rotation matrix, so if we counterclockwise rotate a degree, so the matrix is cosine a, negative sine a, and sine a, and cosine a. So in our case, so we're going to rotate clockwise. So a is actually negative 90 degree. So in this, then actually we can compute this r easily. So which is cosine 90 0. The cosine negative 90 and the cosine 90 are the same because cosine is an even function. So negative sine negative 90 is 1. So sine negative 90 is negative 1. Cosine negative 90 is 0. So this is the rotation matrix for this problem. And assume that we are at the direction here. So in this problem, the initial position is the direction is 0, 1 to the east. So the opposite rule is the following. So if we regard this as a vector, so we have dr, dc, then we can do matrix multiplication for this r times this v. So 0, 1 times this column, we get dc, and negative 1, 0, we get negative dr. So that's the opposite rule for the direction. So with that said, so we are ready to write the shortcode, which actually is sort of straightforward. So first, I'm going to initialize a empty list whose final state is what we want to return, and then rc is r start, c start. So this is the initial position, right? So the direction dr dc, initially it equals 0, 1. So this is the initial direction. So also I want to use a variable called result length to track the length of the result. So once we have rows times column results positions added to the result, we are done. So in order to mimic this sequence for the walking traversing steps, so I'm going to initialize a variable n that is generating walking steps, and also play the role of how to change, where to change directions. So once that's set, so we're going to do the while loop. While the result length is less than rows times columns. So what we are going to do? So we are going to do the walk. So for I in range n over 2 plus 1. So this is the number of steps we are going to walk along this current direction, drdc. So first we want to make sure that we only add results for those positions within the grid scope. So we will r less greater or equal than 0 less than rows, and 0 less or equal than c less than number of columns. So if the position is within bound, so we are going to append this coordinates rc. So next, what we need to do is that we need to update the direction. So the position rc equals r plus dr, c plus dc. So this for loop is the number of steps we walk along the current direction drdc. So after we finish these steps, we are going to update the direction. The direction update rule is here. So dr dc equals dc negative dr. So after that, we're going to finish this one. We're going to increment n by 1. So that's about it for the min while loop. So now we are ready to return the result. So with that said, let's have a look at a special case. Let's do the test. It's running slow. Oh, I see. So forgot one thing. So that is we increment the length of this one by 1. Right. So let's test again. So it passes the case for example 2. So let's test the generic case here. Yeah, it passes the generic case. I guess that's about it for this problem. So let's give a quick summary. So here we are using the rotation matrix following our previous videos. First, we get the places where we need to change directions, and then we use the rotation matrix to update the direction. And finally, so we return the result after the min while loop. So that's actually the last video for this 4 spiral matrix problem in Leetcode. Thank you very much.